Okay, so this application is for ferrous welds, and it's used in carbon steel materials. And you can see the weld here. It's actually used in the new ASME Section 5 Article 8 code that's going to be released. In Appendix 10, specifically, it calls out eddy current array examination for ferromagnetic and non-ferromagnetic welds for detection of surface breaking flaws. So you can see the EDM notches here on this plate match that ASME code for the EDM notches. Typically, these inspections are done using PT or MT, and also for conventional single coil eddy current probes. This particular solution is using the MIZ 21C, the array version, and a Surf-X weld probe. And this probe has 32 coils for the array portion of it, and then it has 2 plus point coils at the end that are in different orientations to be able to get into the toe of the weld. And so the inspection is typically done with 3 passes. You'll do a pass on one side with the plus points up against the toe, and you're using the array coils to pick up the heat affected zone on one side. Then you flip and you do the other side with the plus point coils on the other side of the toe and picking up the other side of the heat affected zone. Then the third pass, you go over the crown of the weld to pick up all of the flaws that are along the top. In the instrument here, you can see this is currently set up for this inspection. You can see the Surf-X weld probe there. It has multiple channels. So you have channel 1 and channel 2, which has your axial and transverse channels for the 32 coil array. And here you have it at 200 kilohertz. The channel 3 and 4 are actually the 2 plus point coils, and one is set up for axial, meaning both coils are picking up the axial, and then the channel 4 is both coils picking up the transverse. And you can notice here it's running at 100 kilohertz. So you actually have independent frequencies between the channels, between your array coils and your plus point coils. So to do this inspection, you just hit start, and I will run across the heat affected zone and into the toe. And this is on currently the transverse, so I'm going to switch to the axial channel. And you can see in the axial channel, the flaws here are oriented in the axial direction, and also the one that's in the toe of the weld. And up here, this upper bar is your plus point coils. So there's actually 2 coils being stitched together in a C-scan view, which is a unique way of viewing plus point coils. And then the lower portion is your 32 coil array. And these upper signals up here are your plus point signals, so you can see them there. And there's a slight offset of the coils, so that's why you're seeing a slight offset of the signals of the same notch or indication. If you switch over to your standard impedance view, you can see the 2 plus point channels, and in the transverse, it goes in a downward direction. In the axial, it goes in an upward direction of the flaw signal. And you can see the slight offset of the 2 coils, and that flip between the signal orientation down and up is a typical signal that you'll see from a plus point. The other indication that you see here is the axial notch on the plate here out in the heat affected zone, and that is being picked up by the array coils. So now I'm going to start a scan again. This time I'm going to flip on the axial transverse. So now I'm on the transverse channel, and you can see the transverse notches here. So I'm going to run this. can see again, I'm picking up the transverse indication in the heat affected zone up here is your plus point signal. And if I switch over to my impedance view, I've got the transverse signal there and the axial channel, again flipping the signal. So that's as you would expect for the plus point. Then the last scan I'm going to do is across the crown. So you just make sure that your 32 coils, which you can see the indication here with the black bar of where the coils are. So you line up the coils on the crown and just run over the crown of the weld. In the axial channel, you can see there's an axial indication there. It's actually, because I was slightly off of the crown, it's picking up that axial out in the heat affected zone. And if you switch to the transverse, it's picking up the transverse there, and is actually picking up some of the transverse in the toe. So that's how you would perform this inspection on a weld. You do it in 3 passes, and you can record up to 10 meters or 30 feet or 60 seconds per scan. And then you can just do those multiple data files if you need to do a really long weld seam and get the full coverage.